wanted to work through another homework problem with you. It's this one here from Module 5, Problem 18. And so we've got this fact that about 8% of the population is nervous around strangers. So let's say the event is one person is nervous around strangers. The probability of this event then is 0.08. So let's suppose two people are randomly selected. What is the probability that both are nervous around strangers? And then we'll come back to the second question later. Now, stop the recording and ask yourself, is the event two different people being nervous around strangers? Are those events independent? These events are independent, and you can think about this as if, let's say I'm nervous around strangers and you, the viewer of this video, is nervous around strangers. The fact that I'm nervous around strangers has nothing to do with whether or not you are, and vice versa. So we're going to say that these events are independent, so the probability that both randomly selected are nervous around strangers is 0.08 squared, which you can verify with a calculator, should be 64 thousandths. Come on, pen. 0.0064. 64 thousandths. I'm going to check that with a calculator. I'm not. Oh, I don't want Siri. Go away, Siri. Good. Siri is not here. Go away, Siri.
Sorry, you'll need to continue in the app.
That's fine, Siri. Nobody cares. Okay, I did that right. Good for me. So now we're going to type that answer in. 0.0064, check answer. Hooray. Okay, now this one I found to be much more difficult. The probability that at least one person is nervous around strangers. So look at page 283 in your text for a great discussion of at least probabilities. And you'll find that at least probabilities are computed in this way that they are because the phrase at least means greater than or equal to. So if we want to know the probability that at least one person is nervous around strangers, and I'm going to abbreviate to nervous, that's 1 minus the probability that none are nervous. Let me get a new page up here. So, new page. No, I don't need to save that. So the probability at least one nervous is 1 minus probability none nervous. So now you might be thinking, oh, well, that's 1 minus 0.08. Well, that's not true because what's going on here is we have to figure out the probability that none of the people are nervous. And the way that works is that we need to think about independence here. So the probability that none are nervous is going to be